Welcome to second part of flexural analysis of cross-section of the T-beam or T-beam cross-section, you can tell. I already told you, flexural analysis means finding ultimate MR of the cross-section. Okay. Now, procedure. Just to follow the procedure, everything you will understand. See, when you solve a problem, you follow the procedure. It will take you through till the answer. Data required: BF, DF, BW, AST, D, FCK, FY. I told here. See, this is a cross section. These all already explained. Breadth of flange, depth of flange, effective depth, AST, BW. This is effective cover tension reinforcement that you require to get a D value from capital D. See, capital D is required, no doubt, but structural calculation, capital D will not come. So all terms I explained here. As usual, D equal to capital D minus effective cover to tension reinforcement. Next. After getting all these values, means what is required in the data from the given cross section, when you get all these values, write the value of FCK and FY. Okay, I should not tell here. Based on given grade of concrete and grade of steel. That much you should write if you want. Okay. Then, based on Fy, get XU max by D. Okay. Now, procedure will be continued. We will continue. Remember, very slowly I will give procedure. There is a reason. Lot of confusion for a flexural analysis for T-section, especially when neutral axis lies in the web. People get confusion fully mixed up. Nothing to worry, I will make fully clear. Follow my class from beginning up to end. Remember, one part I already uploaded. That is not procedure. That is some principles and concepts that you have to thoroughly study. Then, start. I already told earlier, little earlier, because I rubbed the board, data, which one? Breadth of flange, depth of flange, BW, AST, then FY, FCK, I think that's all, FCK. Then I told, based on Fy, get XU max by D, that much over. First step, location of neutral axis, that is to find XU. Right here, this is actually not required, but usually systematic. Let XU be depth of neutral axis from extreme compression. Remember, neutral axis red color, green color, as usual. Let XU be depth of neutral axis from extreme compression. Now, something I am telling in the class. See, and I used red color here. Make a note, this red color is not your red used for XU max by D. That is red, no doubt. This is warning or important for that one. I am telling red color. What I tell you right here. See, I will dictate now. For flexural analysis of T-section, neutral axis can be in the flange or neutral axis can be in the web. If it is in the web, accordingly we decided earlier case 1 and case 2. Case 1, neutral axis in the flange. Case 2, neutral axis in the web. For case 1, neutral axis in the flange, XU is less than DF. For case 2, for neutral axis in the web, XU is more than DF. That is very simple to understand. But remember, what happens is confusion starts. How to proceed further? If neutral axis lies in the web, because there are two types are there, based on nature of stress distribution for flange. And one more important, most important, flexural analysis of T-section, that is to find ultimate MR, the most important. The only important is how to get XU. Once you get XU, there is nothing, because expression for ultimate MR is given in IS code. Oh, people are happy. Oh, good, sir. But how to locate neutral axis? IS code has not given. Therefore, one should confirm the XU, whether in the flange or if it is in the web, type A or type B, one should fully confirm it, and you finally write this is the value of XU, then there is nothing. Simple substitution in the formula. Therefore, the most critical part of this entire class, part 1, part 2, part 3, flexural analysis of T section, completely stands on one concept, location of neutral axis. Write that much here. Some will tell, sir, it's a story, half page coming. Write half page. If you are serious, write. But you see that it will not disturb the procedure here. Very important. Okay, start. Let X first neutral axis. Let XU be depth of neutral axis, I told, from extreme compression edge. Now, immediately, one note. See, this note actually is for understanding. Whatever I tell note, if you are solving a question in examination, etc., don't write those things. See, neutral axis can be, see, we just now told, let XU be depth of neutral axis from extreme compression edge. We still did not wrote or considered whether neutral axis lies in the flange or web. So, note, neutral axis can be in the flange, or can be in web. Right now, we have no idea. See, I told, right now, we have no idea. Usually, when somebody takes a class, people write what? In exam also write, let us take means us. We have to go, we use the word we. But very sorry, in this we, don't include me. Just for fun I am telling. Because I have full idea. You give a cross section to me. Within 10-15 seconds, I will tell, sorry, if it is in the flange, I will tell in 5 seconds, 10 seconds. If it is not in the flange, if it is in the web, maybe 10, 15 or 20 seconds, I will tell correctly. If it is in the web, is it type A or type B? How means you don't bother. I can decide. So therefore, it is we, don't include me. You don't write, sir only told we. No. It is a usual phrase to write we. Okay, we have no idea. No idea. But right now, we have no idea. About what? Whether neutral axis comes in the flange or web. Right now. Therefore, proceed systematically as told in the class. You proceed systematically as I am going to tell in the class. How class? Coming up. How? Some will tell how. Coming up now. Okay, coming up. Leave it. Initially assume neutral axis in flange. First, see, always in a correct order. Again, I will tell one more thing. Suppose a T section comes to me for analysis. I will not assume in the flange, then if it fails, I will take in the web with the type A. Suppose it fails once again for a type B, I will not do it. I will take my calculator, look at the question. Within no time, say 10, 15 or 20 seconds maximum, I will tell neutral axis there with that condition. Okay, that is possible for you also. Don't think I am a Superman. I am also like you only. Only thing is, when I go for structural classes, concepts I am considering systematically and I understand everything. I don't tell by-hearted concepts or some, see, I don't have anything in my hand. Complete empty. Therefore, you write there, assume neutral axis in the flange. Systematically follow the steps. That is, note, examination, don't write case 1, case 2 like that. That is to understand. For your note, it is case 1. Case 1, okay. That is, you are assuming XU less than DF. One small sketch here, see, this way. This is the DF, this is XU. Now do one thing, if you look this side, what you can see? You can see a rectangle here. That's very important. Compression side, see, compression side, you can see a rectangle. Make a note. Now, write one important statement. Suppose you are writing examination, don't write there. Now I am writing important statement. Write it. See, this statement I will not tell repeatedly. Every question when you solve, whenever you consider neutral axis in the flange, this statement you have to write. That is, when neutral axis lies in the flange, remember, lies in flange. flange. T section is analyzed for flexure, not for shear, for flexure, similar to a rectangular section of breadth B equal to breadth of flange. That is, or see here, see only compression zone. You can make a note if you want, outside note. See compression zone. What you can see? You can see a rectangle of width equal to what? BF. So this is exactly same as singly reinforced rectangular section, not doubly reinforced. Make a note here. It is singly reinforced rectangular section. So many questions are covered in the class. Therefore, happily write the equation. See, or now, why? Somebody is bound to ask, sir, why, sir? You think, but you have to believe me. If I keep on explaining those things are all, it is never ending. It is not a complete RCC course. Complete course, when it comes, I will explain everything. I told immediately after one more class, I am going for systematic upload of classes from engineering mechanics. There you can ask any doubt. If I feel the doubt is reasonable, I will reply it. Okay. Immediately. Okay. Then, breadth B, remember, breadth B equal to BF, or you can make a note here. See compression side. You don't see tension side, because tension side, concrete is completely ignored. You can see a rectangle here of width BF. That's all. No web is participating there. Therefore, wherever B comes, write BF. Now, one note dictated in the class. Write it here. Note. Therefore, proceed further in the same way as that for a singly reinforced rectangular section. You write so many times he explained. He means me. He explained. Therefore, I will continue the question, imagining it is a rectangular section, but wherever B comes, put BF. Start. Equating, now I should not explain. Singly reinforced rectangular section, very thoroughly I covered. Equating resultant compression force to tension force, Cu equal to U, see, 0.36 FCK into B into XU, that space I left for some other reason, equal to, okay, that is for next purpose, okay, equal to 0.87 Fy into AST. You can remember one thing, whether neutral axis, whether it is a singly reinforced section, singly reinforced rectangular section, or doubly reinforced rectangular section, or it is a T section with neutral axis in the flange, or a T section with neutral axis in the web, whether it is type A or type B, whatever is that, right hand side is always tension force is 0.87 Fy into AST. Why? Concrete completely ignored. So your changes will come only on the left hand side. RHS is permanent for limit state method. Singly rectangle, doubly rectangle, T section of flange neutral axis, T section of web, whether type A or type B, right hand side is always 0.87 Fy AST. Okay. Now see what to do. This is the equation. I write here, substituting, get the value of XU. See, XU I told, as usual, what color? Green color. Substituting, get XU. Okay, XU over. Now what to do? Usually offline class I will ask, what to do? Sir, we considered neutral axis in the flange, sir. So we are assumed that your XU is less than DF. We know the value of DF because numerical question. We will compare the XU value with the DF and decide whether the assumption of neutral axis in the flange is correct or not. I will tell them, no. I will tell once again, for you also I am telling, no. Now answer the question. I will wait for some time. Why no? No, because I told so many times earlier, make a note, limit state method. Whenever you get XU, immediately, whether it is a singly reinforced case or a doubly reinforced rectangle or a T-beam or T-beam of neutral axis in the flange or web or amoeba section, whatever is that one, amoeba for fun only, get XU. Compare, I'll do one thing, in a box I'll write, in future I'll use red color box, red color box. Once you get XU, note come warning, limit state method. So in future I will call this as limit state method warning. Only note, see, compare whatever XU you got, your XU with, okay, there is no place there, I write this side. Compare whatever XU you calculated with XU max. Make a note. You already know XU max by D, so get XU max. That I should not tell. First get it. So what you can do is, okay, 1 minute, I tell systematically. Get XU max, okay, systematically, more clearly. Get XU max. How? Right here. Because we already know XU max by D, so get XU max and compare your XU, whatever XU you calculated with XU max. Okay, I'll come this side now. Okay, XU max. Red color continues. And decide the value of XU we have to consider. I think that much is sufficient. But still I feel teacher's instinct. Once again, make a note. If your XU, first of all I should not tell, or make a note. Less means less, equal means equal, but more means equal. I told it so many times earlier. Okay, now start. That is, if this XU has nothing to do with your neutral axis in the flange or web, that your assumption all later. That all will be later. That is, if you get XU, okay, same color I will maintain. If it's late also no problem. Systematic means systematic only. If XU comes less than XU max, cross section is under reinforced. That is, okay, XU remains as it is. See, XU remains as it is. But if your XU is more than XU max, one statement you have to write. What statement? That is, I will dictate here. One statement you should write it. Cross section is over reinforced. For over reinforced section, you cannot use the entire reinforcement provided for strength calculation, or simple language for finding ultimate MR of an over reinforced section is taken equal to that corresponding to a balanced section. Therefore, if XU comes more than XU maximum, you write, take for all further calculation XU equal to XU max. Your calculated value will vanish right there. If the calculated value of XU is more than XU maximum, calculated value of XU vanishes. For any, see, right here, for all further calculation, your XU will become equal to XU max. Once again, less means less, equal means equal, but more means equal. Okay, sufficient. Someone will tell, he told it 100 times. Okay. After telling 100 times also, 101st time, someone will make a mistake. Okay, now, I'll continue now. I'll rub the board and continue. So this much steps systematically write. Little slowly I am telling, so that at the end of the class you will realize why systematic approach is required. See, I was cleaning the board, suddenly remembered one thing. Okay, see, I wrote the equation here. There's a B here. Where is B in T section? In T we have got BF and BWF. I got right. I told that wherever B comes BF, in the bracket right here, wherever B comes, BF. Okay, I forgot it. You should write there only. See, this is the equation for rectangular section. Wherever that B is there, replaced by BF. Okay, now it will be clear. Anyway, note, actually, this is because of successive rubbing of the board. If electronic board is there, I don't have to waste time. All I have to do is just slide this way. Okay. Now, based on the assumption of neutral axis in the flange, that is XU less than DF, we got value of, this full is a note. See, this full is a note. Everything is note. Actually, note means not required, right? Now, based on the assumption of neutral axis in the flange, that is XU considered less than DF, we got the value of XU and also decided value of XU to be considered. That is limit state check. So, now you know the value of XU. Now, time has come to verify whether our assumption of neutral axis in flange is correct or not. Therefore, okay, verify it. Time has come. Therefore, remember, this full is a note only. Sir, compare XU with the DF. Case 1, your XU comes less than DF. You don't know. When you solve the question, when you compare XU with DF, case 1, XU less than DF. Therefore, assumption of neutral axis in the flange is correct. Perfectly correct. Good, happy, very, very happy. Right. Therefore, see, right here, therefore, neutral axis, you can write here, correct. That is what? Neutral axis really, actually note, really lies in flange. Right here, we are so happy. Why? No confusion, nothing. That headache part of web neutral axis, web is not there. Therefore, proceed further to find ultimate MR in the same way. In the same way as a rectangular section, that is, which rectangle? Singly reinforced rectangular section. But one important, replace the term B there by breadth of flange. This I told already. It is same as rectangular section. Wherever you get B, replaced by BF. So, if under reinforced, ultimate MR equal to, see the equation, this you know it. Now remember, I am using only IS code expression, double I am not doing. 0.36 into XU by D into 1 minus 0.42 XU by D BD square FCK. That is based on CU into A. But remember, wherever B is there, BF, see here, or MU based on TU into A. 0.87 FY into A into D into 1 minus A FY by BD FCK, double right. Okay, replace B by BF. Any one we can use, your choice, you can write there. We can use any one, no problem. Both will give same answer. But if the section is over reinforced, use MU equal to CU into A only. Remember, use this only. Do not use TU into A. That is double right, do not use. No. Do not use this TU into A. Already explained earlier. You can make a note. If it is under reinforced, you can use any of the, remember, first of all, neutral axis in the flange means section is rectangular. Wherever B comes, BF. Okay. Same as rectangle. Under reinforced means any equation, either CU into A or TU into A. But over reinforced means do not use tension equation. Right here. You can use, I told you earlier, but some corrections are required. Why you want to struggle? Therefore, over reinforced section, never use ultimate MR based on tension. Remember that one. Over reinforced section. Never use expression for MR, ultimate MR, based on tension. Compression you can always use, but some extra concepts are there. I told I will explain in the star class. No, sufficient request has not come. So I am dropping it now. Okay, now over. Happily get MR and over now. Therefore, solution over. Solution over. Now this is compare XU with DF. Case 1, when XU comes less than DF. Even equal also will do. Even equal also will do. Should not come more. Okay, now what I will do is, I will rub the board and then I will tell what I will do now. See, I won't repeat again. That much you should have, what? That much concentration you should have now. Now I will do one thing now. I will write here, see, after comparing XU with DF, suppose case 2, you get XU more than DF, what to do? I will start from here. Okay. Less than DF means over, solution is over. So more than DF, that is actually this is the most important part of this entire class. That is 3 parts together. This is the most important. If this is clear, everything is clear. Okay. I will write in front of you only. One note, some will tell how many notes. Yes, I believe in perfection. See, note, after comparing XU with DF, if we get XU less than DF, that is case 1, what to do? Already over. Problem closed. But now, let us continue how to proceed further if we get XU more than DF. That is, it goes to case 2. Okay, this is a note only, right? Now, procedure continued. Again I write, after comparing XU with the DF, if we get XU more than DF, then one statement you write, then that is assumption of neutral axis in flange is wrong, not correct, either wrong or not correct, or that is, we can tell what? Neutral axis will be in the web, Okay, write that much. Now write neutral axis in the web. Now, therefore, we have to once again find the value of XU, considering neutral axis in web. That is, we have to go for case 2 of XU more than DF. Okay, 1 minute. One more note. All previous calculation gets cancelled. Even that XU we got earlier also gets cancelled. Why? Because that is the value of XU by using equation when neutral axis lies in the flange. If the neutral axis lies in the web, there is separate equation for XU. Therefore, everything cancelled. That is, we have to start fresh. Fresh means again we have to find XU, but this time considering neutral axis in web. That is, XU is going to be more than DF. Okay, now one powerful note, again note. One note, again note. When neutral axis lies in web, that is xu is more than df. How many times I am writing, I don't know. Df. There are two types based on this, all you write outside, based on nature of compressive stress distribution for flange, which is thoroughly explained in previous class. Therefore, once again, go to previous class, understand everything, that all concept, and then come back. Therefore, to make it more clear, previous class, that is part 1, that full screen, which covers these two types, will be displayed once again now for few seconds. What I will do, I will stop the recording now. Previous part, that small portion, 5 seconds, I will cut it and paste it here. That I will do, no problem. So that once again, then I will continue the procedure, what to do further. Okay, so that I will do it. So now you can, in the screen, you can see the full screen of neutral axis in the web with both the types, type A and type B, with full explanation. Very, 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 very thoroughly explained earlier. So I told last time, if you are serious, you have to go through it. Okay, I'll continue. Okay, I'll continue. I forgot to put the mic on. See, suddenly same problem. Okay. So, consider neutral axis in web. That is your xu more than df. See, one rough sketch. Remember, this will not tell you type A or type B. Neutral axis in the web means xu more than df. Okay. When the neutral axis lies, when neutral axis lies in the web, that is xu more than df. There are two types based on nature of compressive stress distribution for flange. Just now, I inserted that portion for you. That is case 2 type A or case 2 type B. Right now, we do not know which will come. And remember, this is only a note, not a fair copy. A note only it is to understand. It's only a note. Now, continue. See, neutral axis in the web, one thing guaranteed, xu more than df, but which type we do not know. So, consider neutral axis in web, that is the case 2, that is the moment you take neutral axis in the web, your xu is more than df. Okay. But with uniform compressive stress distribution for flange, df less than 3/7 xu. See here, df is here. The junction is, I told you this is a junction. Now further, I will not tell because so much explained last time, full around 15 minutes, and just now one flash is given for you. So go through it over. Now see. Now one note in the class. This is important. Now see. One note. Derivation is done in such a way that, see, now your compression is this full compression. Here, now this full is compression. So what is done is, this portion is a rectangular section of width BW. These are the flange outstands. Okay, therefore, derivation is done such a way that this is separately considered, this is separately considered. Outstands are, see, this is BF, this is BW. This one plus this one together will be equal to BF minus BW. Okay, anyway, derivation I am not going. I will put the equation. But remember, I do not have anything. Actually, IS code has not given equation for neutral axis. So you should by heart it. I write the equation now. I got confidence. See, but remember, when I read the equation for neutral axis, I am not worried how to write, who I forgot. See, I am very good in forgetting, but technical matter, I will not forget. I read the equation here. Equating Cu to Tu, 0.36 FCK into BW into XU, color, XU means color, BW into XU plus 0.45 FCK, okay, into, see, actually I am deriving now, you do not know, I am deriving it, into BF minus BW into DF equal to same thing, 0.87 Fy into AST is the equation when neutral axis lies in the web and if stress distribution for flange is uniform. Okay. Now, how I got it, you don't bother. I will tell once again, looking at you only. 0.36 FCK into BW into XU plus 0.45 FCK into BF minus BW into DF equal to 0.87 Fy into AST. Equate Cu to T. Okay. Now, one confusion. I will give a note for you now. Some people will tell, sir, how to remember it? I will tell a hint for you. Make a note. Right now, make a note. Right hand side is always 0.87 Fy AST. Nobody in the world can change it. Left hand side, two terms are there. Why? One is for this area, one is for outstands. I already told you, these two outstands together equal to BF minus BW by BW. Or how to remember is, this is rectangle of what width? BW. So, this is same as your Cu for singly reinforced rectangle section. This everybody you can write here. This is same as Cu for singly reinforced rectangle section. You know it. But only one thing. Their formula is 0.36 FCK into B into XU. B, how much B? See, rectangle is here. B equal to BW. Okay, that you have to remember. This is universal, 0.87 Fy AST. How to remember this term? I will tell you a small hint for you. In the IS code, see, we should write a note. In IS code, they are given expression for MU. Write somewhere outside, MU. But remember, they are given for MU limit. But limit you can't use. So, they told the equation when XU equal to XU max. Analysis problem, you cannot take XU max. Take XU as XU only. Then the formula in the IS code is 0.36 into XU by D into 1 minus 0.42 into XU by D into BW into D square plus 0.45 into FCK into BF minus BW into D into, you see, 0.45 FCK into this area into DF into D minus DF by 2 is the equation. See IS code. Okay, it is given. I will tell you page number later or I will tell now only. See, IS code, page number all I am very weak in remembering. See, that is one thing I find very difficulty. Page number, yes, flanged section. Page number 96, they are given two equations. First time they are given. But remember, they told there something like DF by D limit ratio. No. So many people, they instead of this stress distribution, they consider a ratio of DF by D. Utter nonsense. That is only for limiting value. It is not valid for general section. So, you should not see it. See, I will tell the people, okay, use the limit, ratio. What is there? Limit is there. When limiting value is there, how you can take it? They will be without any answer. So, remember, do not see those things all. IS code has told for limiting value, we want general equation. Okay, now, there, see, this equation is given. 0.36 into XU max by D. No XU max by D, take xu by d into 1 minus 0.42 xu max by d into fck bwd square. Okay, that's the equation given there for that one. What you have to do is 0.45 fck. That's correct. Now how to remember is, see, this I told easy, first term. For rectangle, same as single line post. RHS is always constant. This term, how to remember is the second term there without the bracket. Without the bracket. Because, I will tell the reason for you. This is compression force. That is lever arm. Force into lever arm will give mu. But that is for mu. For mu, see, when you do calculate mu, bracket is there. But we are only interested in force. Therefore, this much is the force, Cu. This much is Cu. Therefore, Is, see, this is not there. Don't see this one. That you already replaced here. The second term, how to remember? See, this you can remember very easily. How? Same as rectangular section of width equal to BW. See here, BW. Single line post section. Right hand side is same, 0.87 f into AST. The second term, how to remember? Whatever is second term in MR equation is given IS code, there, skip that last term, that is actually lever arm. Lever arm. Skip that term. Remaining is see, 0.45 fck into BF minus BW into DF. Over. Make a note if you are finding difficulty for remembering. This is a formula for equation. Now see, all over now, I'll remove this one now. These are all for tips only for you. Okay, now, substituting, get the value of xu. Get the value of xu. Then, what to do? Some will tell, sir, compare xu with this assumption. No. I told so many times, in limit state method, whenever you get xu, always you apply immediately apply limit state check or warning. Sorry, now I am not telling. Compare xu with xu max. If xu comes less than xu max, take xu as it is. In case xu goes above xu max, take xu equal to xu max, apply the check and decide value of xu to be considered for proceeding further. I should not tell that one, red color. Okay, over. Now we got the value of xu. Now I will rub the board. This all I will rub and start once again fresh. Okay. See, continued. You should write neatly in a book. Again note. See how many notes, I don't know. Now we know the value of xu considering neutral axis in the web with uniform compressive stress distribution for flange. Okay. That is, assumptions are there. What do you do? Compare xu with df. We assumed what? We assumed xu is more than df. Compare xu with df. And also find the value of what? Find the value of 3 by 7 xu. 3 by 7 times of xu and compare that, which one? Compare df with 3 by 7 times xu. See, what is the assumption here? Compare xu with df and df with 3 by 7 xu. Suppose we get really xu is more than df. Oh, see here, first assumption. And also df. See there, less than 3 by 7 of xu, then it means that our assumption of neutral axis in web, again I told this assumption, web with uniform compressive stress distribution. I am writing short because you should write distribution for flange is correct. Then proceed further to find ultimate MR by the formula. I'll give the formula for I'll give formula for ultimate MR. This also I am removing. Okay. By the formula here, ultimate MR, that is, it starts from here because long equation MR, that is mu equal to 0.36 into xu by d into 1 minus 0.42 into xu by d into bw, not b, into bw d square into fck plus 0.45 fck, that's the area. Again I am deriving now into bf minus bw into df into lever arm into d minus df by 2. xu by d is there. Use this formula. Sorry, note, this is given in IS code. But one warning, IS code has given xu max by d. Don't consider it. That is only for limiting value. Okay, use it now. Right, code given. Before substituting, find xu by d. Better 4 decimals so that accuracy. Okay, substituting, happily find ultimate MR mu over. Now that is if what? Your xu comes more than df and df comes less than 3 by 7 xu. Okay, now further procedure. Why is further procedure? See, there is no guarantee. This assumption may not be correct. If it is correct, happily close the question. Okay, now last part, what to do if this assumption is not verified. 1 minute. I rub the board and last round I write procedure now. Only one round. Okay. Now further procedure. See, after comparing xu with df and df with 3 by 7 xu, if assumption of xu more than df, see, that is what we made earlier, and df less than 3 by 7 xu is not satisfied. See, these are the assumptions that is for neutral axis in web with uniform compressive stress in flange. If it is not satisfied, then it means that our assumption of neutral axis in web with uniform compressive stress in flange is wrong. That is, case 2 type A is wrong. Therefore, go for case 2 type B. Note, all calculations gets cancelled. Once again, fresh xu you have to calculate. Because why? Wrong equation. Okay, now further procedure. I'll continue here now. See, continue. Consider, this is so simple to understand. See, I'll give one more note. Sometimes what happens is, there are two assumptions here. See, both to be satisfied. Remember, you can make a note here. See, you can make a note. Both this assumption to be perfectly to be satisfied. Then only your type A. If any one of them is not satisfied, full gone, fresh calculation. Okay. Consider neutral axis. Once again in the web only, don't go to flange. Flange already rejected you. When I do numerical, I will tell this one. Once again in the web, that is what? That is your XU is what? Neutral axis once again in the flange web only. That is your XU once again is what? XU is once again more than DF, but with non-uniform compressive stress distribution for flange. See here, it will come up to here, then turn. See, junction is here. If you see the flange here, up to here in the flange, see, the red color will come here. See, the red junction will come somewhere here. So, this much uniform, remaining non-uniform. So, these are the assumptions. Okay. Then, go for it. Then, again find XU. Again find XU. Sorry, I have not shown the AST here. Okay. Again find XU by CU equal to TU. This time, there's a correction is there. Remember, formula is same as last time. Make a note here. Formula same as last time, but DF gets cancelled. The term DF gets cancelled. In that place, a new term called YF will come. Now, what is YF? What is the meaning of YF? How it is decided? That all will take at least half an hour to explain. No, I am giving procedure. The formula is, see, once again, 0.36 FCK into BW into XU. This you already know it. Just little earlier you wrote it. So this into XU plus 0.45 FCK into BF minus BW into not DF into YF equal to 0.87 FY into AST. Okay. Now, doubt comes, how much YF? As per IS code, that YF, that is some imaginary depth of flange, a part of the flange is removed. Reason in the regular batch, I told the reason for them. For you formula, YF equal to, IS code has given 0.15 times XU plus 0.65 times DF. But remember, but condition, YF is not to be taken more than DF. This I will explain when I do a problem. This remember, actually this is given in the IS code. So all are happy. See, in the MR formula also, DF vanishes, YF is there. So you can see MR formula, first term you know it, right hand side you know it. Here, instead of DF, it is YF. Okay, this but over substituting, get XU. Okay. Then I will not go for one more case now. I will rub here only. Get XU. See now. Next step. I will close the question now. Get XU. Remember, limit state what? Warning or check required and decide XU. This I will not tell. Whenever you find XU, you should compare with XU max. That I will not tell now. Okay, XU decided. Then, see. Also find, see, now one thing, XU decided. XU over. We got. And decided. We got and decided. Okay. Based on what? Warning. Decided. Then further. See. One more. Find. The color mixing. Find that other number. 3/7 of XU. 3 by 7 of XU. Then compare XU with the DF and also DF with 3 by 7 of XU. 3 by 7 of XU. Now, see, this is the last chance. No more chance. Therefore, we will get, surely, why? No other way. We will get guaranteed XU more than DF. Oh, correct. And DF, I write here, and also you will get that DF, what? We will get DF more than, we will get it, 3 by 7 of XU. Right. Therefore, over assumption of neutral axis in web with non-uniform compressive stress for flange is correct. Correct. Over. It will come correct. Proceed further to find MR. Ultimate MR. Forgot. Okay, bad. And some will tell working stress method. Ultimate MR. Ultimate MR mu equal to I'll put the equation now again. Without seeing anything, I am writing by deriving. I am actually deriving now. 0.36 into XU by D into 1 minus 0.42 into XU by D into BW into D square into FCK plus the stress there 0.45 FCK into BF minus BW into YF into D minus, earlier DF by 2, D minus YF by 2. Actually, remember, it is given in IS code. Okay, over. Now, first find which one? YF. Using the formula YF equal to 0.15 XU plus 0.65 DF. And consider IS code condition of YF not to be taken more than DF and decide YF to be considered. This all I will explain when I do numericals. Okay. Now YF over. Next. Before substituting, please find XU by D. Better up to 4 decimals. Substitute, happily get ultimate MR, and our class is over. More and more clarification I will give in the numericals. I will take very slowly numerical. Okay, now note, this is the last class. I am uploading this something from RCC, something from structures, etc. Now onwards, uploading will be only systematic. I will give details little later. Okay, procedure over. We will meet in the next class where part 3 we are considering numerical. See, everything is important. Now show me one place where this much explanation is given. Okay, in the comment box write who has given you explanation and concept more than this much, or at least equal this much. Okay, thank you.